Welcome back. All right. Let's take a look at another identity. This one's a little bit different. I got a couple of fractions. Saying these two fractions are equal. 1 minus sine x over cosine x is equal to cosine x over 1 plus sine x. Make sure I got all of it. Yep. So the idea is that we need to make something happen algebraically. One of the things that I don't like doing is something to both sides, thinking this is a true equation already and doing the same thing to both sides. It's not really wrong to do that, but it's not as good of an algebra exercise. And some instructors ban the practice entirely. So if we see these two fractions are equal, we might be inclined to do some kind of cross multiplication. But although I'm not opposed to doing the same thing to both sides of the equation, working on both sides, assuming that they're equal, because we're trying to prove that they're equal, and showing that it does not lead to a contradiction, that's still a little bit weak in my mind. It does tell us what we can, give us some ideas for what we can do. So, in this problem, the point here is I'd like to avoid cross multiplication, mostly because the term cross multiplication is kind of meaningless. It's a bullshit term. We keep saying cross multiplication where you multiply the top and then the bottom and the top and then the bottom. And we use that same phrase in lots of different contexts, which means it's not a good phrase. It's too commonly used. So mostly I just hate that phrase. Some teachers are like that, but would not do things to both sides. Anyway, I don't want to do cross multiplication. Don't want to cross multiply because that's assuming that this is true already. And that's what we're trying to show. If I hand you a trig identity that's in doubt and you start doing cross multiplication, you're assuming what you're given is true, and your job is to prove what you're given is true. So we don't want to do that. But we can take inspiration from it. What I mean is that we could do 1 minus sine squared times 1 plus sine squared. Sorry, 1 minus sine x times 1 plus sine x is cosine x times cosine x. This will show us what's going to happen in this problem. And then we can just think about how to make that happen. If I take 1 minus sine x times 1 plus cosine x, that's 1 plus sine x minus sine x. That cancels out. So although we wouldn't want to use this as our proof, we can see what this identity is based on. This identity is based on this Pythagorean identity. Cosine squared is 1 minus sine squared. So let's see how we could use that. This identity is based on cosine squared is 1 minus sine squared. So I'm going to start with this cosine over 1 plus sine. And we're going to do the great trick of mathematics. We're going to multiply by 1 as if we were adding fractions. If I think about this side, if I think about these two as the two denominators, my lowest common denominator is cosine and 1 plus sine. In cross multiplication, that's the LCD that we would be multiplying by. And so, but since we've seen that our inspiration is going to be this cosine squared, I'm going to make that cosine squared happen. Oops, I got ahead of myself. Now it's just giving me a whole extra factor of cosine, which we don't need. I'm going to make the cosine squared happen by multiplying the top by cosine x and then the bottom by cosine x. So when we multiply this, our denominator is just kind of unsatisfying 1 plus sine x times cosine x. But our numerator is cosine squared x. Now I'm going to replace the cosine squared with Pythagorean identity. Cosine squared is 1 minus sine squared. Now we're going to look at what we have brought. And we look at what we're aiming for. We're aiming for the left-hand side. So I want a 1 minus sine squared left over in the numerator. And I just want cosine x in the denominator. So when I look at where I'm at right now, I got to think, I got to get rid of this 1 plus sine x. And so this problem turns into the previous problem. I'm just going to factor the numerator to get rid of a 1 plus sine x. The numerator is 1 minus sine squared. So I can factor the numerator. As the difference of squares. And algebra is happening. That was a weird thing that happened in this problem. We had to look at that 1 minus sine squared and see the difference of squares. Just like if it said 1 minus a squared, 1 minus a, 1 plus a. We would think to do that because we look at the denominator and see there's a 1 plus sine x in our denominator on this step that we need to get rid of. Because our original had a cosine x in the denominator, which we have, but not this 1 plus sine x. That has to get canceled out. So experience says factor out the numerator and cancel it out. So this problem really turned into the previous problem. It was just harder to see the factoring because it wasn't just a common factor of 2. Any questions? Comments? So when we were first looking at this, if this equation is going to be true, then if I multiply everything by a common denominator and multiply both sides by cosine, and then also by 1 plus sine x. Then I get 1 minus sine x times 1 plus sine x, and then cosine squared. So that showed me that if this equation is true, a big important part of it is going to be that cosine squared is 1 minus sine squared. So that's why I decided I'm going to make that cosine squared show up by taking this cosine squared and multiplying by cosine over cosine. Well, we could have done that same thing over on this side, multiply by cosine over cosine, and then the 1 minus sine squared we fill into the denominator. So good news, there's more than one way to get at the information that you want. Bad news, there's more than one way to get at the information that you want. Because we could have done this problem starting on the other side and still multiplying by cosine over cosine. Any questions? How's everybody okay? Trig Identities week is always awesome. Not quite as good as Shark Week. I got to figure out a way to combine it. Does Shark Week still happen? Now it's just combining sharks with other things. For a long time, all there was combine two creatures into one creature. Sharktopus. I can't think of other examples because right now all I can think of is parawas. That's a treatment that I wrote. Parawas is obviously piranhas and chihuahuas. All the ferocity, or all the sharp teeth of piranhas, and all the ferocity and downright meanness of chihuahuas. Piranhas walking around on land. I even could see like scenes from, I could envision scenes. They're playing in my head in the trailer for piranhas. Like there's a person like walking down the hall, and then like a little chihuahua comes walking around, but it just looks like a chihuahua. And it's doing a little chihuahua thing. It's probably got one eye, its eyes are bulging out because it's been badly bred. I mean, it's been bred with piranhas, so it's dangerous. But it's like shaking. And so because, you know, chihuahuas are always frightened. That's why they're so mean. So it's like shaking and it comes around the corner. And the guy's like, oh, are you lost, little chihuahua? Oh my gosh, you are so cute. And then he reaches out like this. And it's a close-up of the chihuahua, the parawa. And it's like, oh, and then all of a sudden its eyes go mean and it opens its mouth. It's got razor sharp teeth. It's like, yeah. And then it leaps off the screen. And all you hear is like, ah, and then like splattering of blood. Blood splatters across the screen and rolls down. And it just says, parawas. It's a whole movie. Sci-fi. Call me. But now they're like, oh, but where's the weather event that's in it? Damn it. So now I'm just trying to combine sharks with trigonometry. Sharknometry? No, that's just the study, the measurement of sharks. Shigonometry or shargonometry? Sharkonometry? No, that's back to the beginning. That's just, there's no trig in there. Sharks? No, that's not it. Anyway, it doesn't work. Parawas, perfect. It's on the internet now, so my idea is about to get stolen. But then again, you'll know what happens if like partway through the semester, I disappear, and then like next semester, parawas shows up on sci-fi. Oh, escaped. Now making movies. If I do that, I promise I will go full Hollywood. I'll start wearing like jackets, but I'll like roll up the sleeves. I'll stop wearing socks. I'll make sure my stupid pants are like short and peg enough that you can see that I'm not wearing socks. I grew up in the 80s, so this is what it's going to look like to me. And my hair will be all slicked back. It's the 80s, so I'll have to shave. So, what are we talking about? Oh, yeah. So, the most important thing to do is something. You're just trying to make some algebra happen. Just trying to make some algebra happen. Make some fractions that you can add. Get some common denominators. Try not to do things to both sides of the equation, although that could give you some inspiration like it did here. How's everybody okay? Parawas idea, not free. So if you steal it from me and go make the Parawas movie, I will come after you. Parawas are an actual thing. I have a bunch in my basement and I will send them for you if you start making money off my idea. That's right. I'm not going to CGI all my chihuahuas. I actually made Parawas. I will send them out. You don't want that. All right. All right, that's going to do it for today. I will see you all on Thursday. We'll talk a little bit more about trigonometric identities.